Alright, linear programming 3.4. Buckingham students will be able to solve a system of inequalities by graphing and determining the vertices of a region formed by the graph of a system of inequalities. And then I should have added, and use the vertices to find maximums of functions. So, a couple things here. The inequalities themselves, these are called constraints. And you'll see why later. And the feasible region is the overlap of the graphs of the inequalities. Okay, for linear programming, it's kind of involved, so I broke it down into several steps. I tried to simplify it, call it VigVim. If you can remember that, it might help you. What I mean there is, what are your variables? What are your inequalities? Graph it. Find the vertices. Plug it in. That's the second, or the second I. Plug it into the function. So sometimes you have to figure out what that function is. And then determine your max and your min. So let's do this example 1 together. I'm going to graph these things because it says use the following system of inequalities as constraints to find the max and minimum value. So first thing I have to do is just graph these guys. So x is greater than or equal to 1. Let's graph that one. I'll tell you what, I'll make these all different colors. So x is greater than or equal to 1. Let's do that one first. Here's where x is 1. And that's just a line going straight up and down. Okay, the next one is y is greater than 0. Well, that just looks like this guy. And so far I know I'm shading greater than 1 and greater than 0, so somewhere in this corner. And lastly, I got 2x plus y is less than 6, so cover up the x value, and I see that my y-intercept is 6. Cover up the y value, I get 2x equals 6, so x would have to equal 3. So my x-intercept is 3. And zoom in and just connect these dots. Looks like I'm just going down 2 over 1. Okay, the point of all this is to find the corners. That's all that matters. So this is 1, 4. This one is 1, 0. And this one is 3, 0. Okay, now that I got the corners, I'm going to make a table. I already made one for you, but you're not going to usually have one made for you. You're going to have to make it. So, you make a table, and you start plugging in these points. So I know that I got 1, 0 as one of them, 3, 0 as one of them, and 1, 4. And here's the function they're telling us to maximize. And this function has x and y's being plugged into it. So, let's see what that looks like. I copied down the function here, and we're going to put the result here. So the first thing is 3 times 1 plus 0. Well, 3 times 1 plus 0 is just 3. Next one is 3 times 3 plus 0. Well, 3 times 3 is 9. And the next one is 3 times 1 plus 4. 3 times 1 is 1, or I'm sorry, 3 times 1 is 3, plus 4 is 7. And so I'm supposed to determine the maximums and the minimums. Well, there's my max. There's my min. And that's how you do, that's the basics behind a linear programming problem. But these are usually word problems. And that's mainly what all these steps are going to be for. See, we already had the variables inequality, so we started at step 3 on this problem. But in a word problem, you're going to have to ask yourself what your variables are, what your inequalities are. Also, the max and the mins, they're always at one of these corners. That's why that's the only 3 we had to test. So we could say the maximum mins are always going to be at one of the vertices. Okay. I got another problem here for you. Different function to maximize, different constraints, but I still set up the table for you. So go ahead and give this one a try, and then I'll put the answers up in just a second, so you may want to pause the video now. Okay, and before I answer this question, let me just say this too. That I kind of forgot to shade here. So, come on, there we go. I was supposed to shade in this triangle here created, but the shading isn't really what's important here. What's really important is the vertices. So on this next one, after I graphed the constraints, I got these 3 points. I plugged in those points to use this function, and I got 0, -12, and 18. Negative 12 is my minimum. 18 was my maximum. That's all there is to it. Let's take a look at some word problems. Oh yes, I forgot. Before word problems, we should take a look at this type of situation because this is definitely a different type of situation. So I'd say go ahead and graph these three first and find those three corners or two corners or whatever it may be. So graph those inequalities, shade your region, and then I'll put those answers up, and then I'll help you from there. So go ahead and graph it, and then I'll meet back up with you in just a second. So go ahead and pause your video now. Alright, so I graphed it and I got something like this, and I didn't get a lower boundary, so this shaded region just keeps going on and on and on forever down that way. I got these two corners, 0, 3 and 3, 4. But because I don't have a lower boundary, I just picked a random point down here for us to just test and see what's going on here. So I picked the point 4, negative 5. It's right on this line. And we're going to test all three of those. I went ahead and started to make my table. So let's plug in all these values. I got 0, 3, I got 3, 4, and then that special one that I'm testing is 4, negative 5. Alright, so 5 times 0 plus 4 times 3, well that's just going to be 12. 5 times 3 plus 4 times 4, well that's 15 plus 16, so that's 31. Now let's see what happens when I plug in the 4, negative 5. So I get 5 times 4 plus 4 times negative 5. 5 times 4 is 20, 4 times negative 5 is 0. So, well, it does appear that this guy is my maximum. Apparently, as I pick lower numbers down here, lower and lower, I'm going to get lower numbers. So, probably not going to be able to figure out what my my max and my min is this way. And so what we would say is that there is no min or no minimum because the region is not bounded, meaning there's no lower boundary here cutting it off so that we could find out where a min would be. This is our max, and this is a point, but it's not a max or a min, and we don't have a min. We can't find it. It's probably somewhere around here, but there's nothing telling us where to even look. So there's infinite things that we could test before we found the minimum. So we're done with that. The last thing, I put it as a summary, but it's a word problem, and I'm going to work this one with you guys because it's pretty tricky. And I remember I said on the last page that we're going to use vim, variables, inequalities, graph it, find the vertices, plug it into the maximizing function, and find your max and your min. So let's read this. As a receptionist for a veterinarian, one of Dolores Alvarez's tasks is to schedule appointments. She allots 20 minutes for routine office visits and 40 minutes for surgery. The veterinarian cannot do more than 6 surgeries per day. The office has 7 hours available for appointments. If an office visit costs $55, and, that should say and, most surgeries cost $125, find a combination of office visits and surgeries that will maximize the income the veterinarian practice receives per day. So, VigVim, first thing is V, identify the variables. Well, it looks like it's office visits and surgeries. So I'm going to say V for visits and S for surgeries. And now we got to write a couple of inequalities because that's the next step according to VigVim. So what are some of my constraints or my inequalities? Well, let's see. The veterinarian cannot do more than 6 surgeries per day. Well, there's one right there. Surgeries has to be less than or equal to 6 for every day. The office has 7 hours available for appointments. Okay, so we can only schedule up to 7 hours, but it looks like everything so far is in minutes. So 7 hours in minutes is going to be 420 minutes. And whatever my office visit is, so my office visit is however many of those I have, it's going to be times 20 minutes each, plus however many surgeries I have, it's going to be times 40 minutes each. and that has to be less than or equal to 420. And let's see, are there any other constraints? Well, I can't do negative surgeries, right? So S has to be greater than or equal to 0. And I can't really do negative office visits, so V has to be greater than or equal to 0. And I think that's it. All right. As I look at this equation, I feel like I could definitely simplify this because I could divide 20 in each of these terms to make it a lot easier inequality to work with. So let's do that. That would give me V plus 2S less than or equal to 21. Okay, I like that one better than that one. It just seems like it'd be easier that one. It doesn't really matter which variable I apply to the x-axis and the y-axis, so I'm just going to call that S and that V. And let's start making our constraints. Well, if everything's going to be positive, I know already I'm not going to be using these quadrants, so that's easy. And surgeries are going to be less than 6, so I can graph that really easily. And so I'm going to say that's at 6. I think I'm going to try to make my graph fit a little bit better. I'm going to make every line worth 2. So we'll do 2, 4, 6. And it's going to be less than or equal to 6. So I'm going to have a graph going like this. And I know that I'm going to be shading somewhere to the left of this because it's less than 6 but greater than 0. So I'm somewhere in between here. And let's go ahead and graph that other line then. In order to do that, just cover up my V. Looks like my surgeries would be at 21 divided by 2, which is 10.5. So let's go there. 2, 4, 6, 8, 10, 12. So here's 11, and there's 11.5. Kind of hard to mark on my graph. And if I cover up the S, I can see that my V-intercept is going to be 21. Well, a little bit hard to mark that as well. So what I can do is I can make, instead of how I made these 2's, what I could do is I can make these 3's actually. So I can do it like 3, 6, 9, 12, 15, 18, 21. Now it fits on there nicely. And I could just take a ruler out and connect my V-intercept and my S-intercept. But just to be on the safe side, I'm going to figure out what my slope is. Now, usually, standard form is AX plus BY equals C. So we would need to have my X term first. Well, according to this graph, my X term is S, right? So I need to just switch this around so that it's 2S plus 1V less than or equal to 21. That means that my slope would be negative 2 over 1. So I'm going to go down 2 over 1. Let's just remember as I graph this, though, that for every 2 I go down, I need to go over 1, but I'm going down in 3's here. So if I was to go down 2 over 1 or 6 over 3, so that makes it a little bit easier to graph accurately. I go down another 6 over 3, and I'm right there, which is important because that point is at 6, 9. And you'll see why that's important in a second. Okay, and then we're going to go down another 6 and over 3. So if I go down another 6 over 3, I'm right here. And that is how we'll end up right at 10.5. So I did that so that I could have at least one point on my graph here that was obvious. Okay, remember I said I was shading somewhere in between these two lines, and now I got to figure out am I shading underneath this line or above this line. So let's go to our inequality real quick. It says V plus 2S is less than 21. If I plug in a 0 and a 0, I'd get 0 less than 21. That's true, so I'm shading on the 0, 0 side. Well, the 0, 0 side is underneath, so I'm shading in here. And now I'm looking for my four corners. Well, look, I already found one. It was at 6, 9. And then I have this one. This is at 6, 0. This one, this is at 0, 0. And I have this one. It's at 0, 21. All right, last step is to make my table. Well, not totally the last step. Sorry, I got the variables, I got the inequalities, I've graphed them, and now I found the vertices. And now I have to plug it in to my function. So let's make my table. I know I have 4 things that I'm going to be plugging in. S and V. And my function, well, what is it? I'm trying to maximize the income. Well, what is my income? It says that I make $55 for every visit and $125 for every surgery. So couldn't I write that as 125 for every surgery plus 55 for every visit, and over here this will be my income, what I actually make. So let's list out those points. I got 0, 0, I got 6, 0, I got 6, 9, and I got 0, 21. Let's just plug it in and see what happens. Alright, well the first one, this is just 0 times 125 plus 0 times 55. That's just going to be $0. That one should be easy. Next one is going to be 125 times 6 plus 55 times 0, which is just 0. Well, 125 times 6 is 750. So I could make $750 a day by just doing 6 surgeries a day. Alright, well, stands a reason that I would make even more if I had some doctor visits in there as well. So plus 55 times 9. So 55 times 9 is 495. Add that to the 750, and we get 1245. And lastly, 125 times 0, meaning I do 0 surgeries, plus I just did 21 office visits. 55 times 21 is 1155. So it looks like I actually have a maximum right here. And so if I was to answer this in a complete sentence, I would say I can make a maximum income of $1,245 if I have 6 surgeries a day and 9 office visits. All right, that's the kind of question you can expect to see on your test. So take a look at some of the homework questions, do those over and over again until you got it down. See you guys on the next video.